Hello and welcome to SUSECON Digital 21. SAP on Google Cloud couldn't be better. Today's session focuses on how SUSE and Google enable you to deploy and automate SAP solutions on GCP. This session shows you how to automate the deployment of SAP HANA HA cluster using the SUSE Linux Enterprise Server for SAP applications, SUSE High Availability Extension, and the internal GCP load balancer. This is Abdurrahman Mohammed. I'm working as the Global Solutions Architect for Google Alliance at SUSE, and it's my pleasure to host Rolf Rook from the Google team in order to co-present today's session with me. Rolf, could you please introduce yourself?
Thank you. Hello and welcome. My name is Rolf Rück. I'm working as SAP Delivery Lead for the Advanced Support Organization at Google Cloud, and I will provide the Google Cloud specific configuration and preparation for you today.
Digital transformation is built on co-innovation. As we can see here in the architecture diagram, we use Cloud Deployment Manager to deploy two compute engine virtual machines, two SAP HANA scale-up systems, a virtual IP address with a load balancer implementation, and a SUSE HA cluster, all according to the best practices from Google Cloud, SUSE, and SAP. One of the SAP HANA systems functions as the primary active system, and the other functions as a secondary standby system. We deploy both SAP HANA systems within the same region but in different zones. The deploy cluster includes SUSE High Availability Extension, which is based on the Cluster Labs Pacemaker High Availability Cluster Resource Manager and CoroSync, a Google Cloud Fencing Mechanism, a virtual IP that uses Level 4 TCP internal load balancer implementation, the SUSE Resource Agents package, including SAP HANA System Replication and the SAP HANA Topology Resource Agents, SAP Synchronous System Replication, and an automatic restart of the filled instance at the new secondary instance. As it's a live session, I would like to hand it over to you, Rolf, in order to start the practical part.
I will now walk you through the steps of the preparation and network configuration for the project. Please bear in mind that the following configuration is for the sake of this demo. It is not recommended and not safe for production use. Please work with your security, compliance, and network team to find the right configuration for your environment. The first thing that we need to do if we open Cloud Shell is to set the project we want to be working with. This is done by the gcloud config set project command. Next, we will check if the project has the quota for what we want to do. This is done by the gcloud compute project -info describe command. And then we will also need to check if resources are available in the region that we want to deploy. This is done by the gcloud compute region describe command. After we check this, we need also to check if we have the right permissions in the project to do all the configuration and preparation. This is done by the gcloud projects get IAM policy command. As you can see, for the sake of this demo, we are using the role owner. Again, that might not be feasible within your environment. Please work with your security and cloud organization administrator for the right scope. After this, we can go ahead and deploy a cloud storage, which will be the source for our SAP HANA installation files for this installation. This is done by the gsutil command. And after this, we will set the project zone that we want to use. In this case, it will be Europe West 4A. Now would be the time to download the SAP installation files and upload them to the cloud storage bucket. We are not doing this for the sake of this demo. So the next steps are the configuration of the network. As mentioned before, please bear in mind that these are tailored to this demo. These are not recommended for the use in production. Please work with your security and network team to ensure your data security. At first, we will create a HANA network with the gcompute networks create command. After this is successfully finished, we will create a HANA subnet with an IP range in the region that we choose. After this is finished, we will have a private network for our HANA systems, but they will be not able to communicate outside of this network. For this, we will need a NAT router, which we will create with the following command. And as soon as the NAT router is created, we will need to provide it with a configuration. This is done with the following command. Please notice the mine ports per VM option. The default in Google Cloud is 40, which is way too low for an SAP installation. So you want to set this to 160, and this should also be done in the production. After this successfully finished, we will need to deploy 3 firewall rules. So our HANA installation is reachable and can be reached. So the first one of the firewall we'll deploy is an SSH to the Bastion host that we will deploy afterwards. The next firewall rule is for HANA internal communication. And the last firewall rule is for the communication of the Bastion host to SAP HANA for ping, SSH, and the Hawk communication. As last step of the network configuration part, we will deploy the actual Bastion host from an image. You will find the steps needed to create such an image in our appendix. And with this, I hand it over for the next part. Thank you.
Now I'm going to use the Cloud Deployment Manager to create a SUSE HA cluster with 2 SAP HANA systems, a primary single-host SAP HANA system on one VM instance and a standby SAP HANA system on another VM instance in the same compute engine region, but with using 2 different availability zones. Before going further, I have already configured the project quota to be aligned with the SAP HANA quota considerations that are listed here. This table shows quota values for a single host scale-up SAP HANA system by VM instance type. As we host 2 node cluster and a Passion host server, consider the values shown in the table to total quota requirements. I have created a dedicated directory for today's session. The directory name is SUSECON. So from my Cloud Shell, I need to change the path to SUSECON directory. Then I need to download the Cloud Deployment Manager template. Okay, so I have the Cloud Deployment Manager template downloaded, renamed, and configured. The template name, as we can see from the Cloud Editor here, HANA HA template. So let's review the configurations. Actually, we have three main configurations sections. We start with the main configurations. My first HANA node name is HANA 01 and second HANA node name is HANA 02. I will deploy the HA cluster in Europe West 4 region. The first HANA node is hosted in Europe West 4A availability zone, and the second HANA node is hosted in Europe West 4B availability zone. The HANA instance type is N1 high memory 32. I will use the previously created VPC network and subnet by WRF. And I decided to use the latest and greatest SUSE Linux Enterprise Server for SAP applications, which is /15 Service Pack 2 for SAP applications. The second section here is regarding configuring the SAP HANA parameters. So the GCP packet name which is used to host the HANA media is TUT 1108, as we can see here. The SAP HANA media is stored inside the GCP storage packet, as we can see also here. So back to my configurations. The HANA SID name is HA1 and the instance number is 05. You need to choose the appropriate password for your SID admin user and the system password. Here I used a temporary password for the sake of this presentation. The latest configuration section here is regarding the virtual IP parameters configurations using the GCP load balancer. I set the virtual IP address. You need to set two instance groups. In my environment, the first one name is HANA instance group 1 and second one name is HANA instance group 2. You need also to set the load balancer name as shown here. And finally, as we configured this environment in a protected network without having public IP addresses for the HANA nodes, I set the network tag attached to the HANA nodes, and I disabled having public IP addresses for my HANA nodes. For more information about the available configurations, please review all available template properties in this table here. So after configuring the Cloud Deployment Manager template, it's time for creating the two HANA instances. We simply create a new deployment by executing the command gcloud deployment manager deployments create. So here's the command. The new deployment name is HANA HA cluster, and we are using the HANA HA template as a backend for my deployment. So once I hit enter here, I can go to the deployments page and I can see the new deployments from the deployment manager page, as we can see here. The entire process usually takes less than 30 minutes, so I have created another environment to avoid waiting for the deployment execution time. Using the Logs Explorer Global Query Preview here, I see that the deployment has been successfully completed on the two HANA nodes. We can see the two log messages here. HANA 01 deployment finished. and same for HANA 02. So from the VM instances portal, I can see the two created HANA nodes and the previously created Passion host server. The HANA nodes have no public IP addresses. I need to access the two HANA nodes via the Passion host server. For the sake of this presentation, I have injected the two HANA nodes with the Passion host server public SSH key, as we can see here in HANA 01, and the same for HANA 02. Please follow the best security practices for your organization regarding accessing the protected instances. So let's provide the deployment from the command line. I need to SSH to the two HANA nodes from my Passion host server. So here, SSH to HANA 01, the same to HANA 02. Then I check the HANA related mount points using the df command. Everything looks fine to me. Next step is to check the HANA database status. So I switch to the SID admin user. Then I list the HANA database info. Looks fine. I will repeat the same steps on HANA 02. The HANA database status looks fine to me here also. Finally, from the load balancer details page, let me try to move it here. Okay, here is the load balancing page. I had the HANA ILP server. In the healthy column under instance group in the backend section, one of the instance groups shows 1 divided by 1 and the other shows 0 divided by 1, which means that HANA 01 is the current active HANA database. When it comes to the SUSE High Availability Cluster verification, we have two ways. The first one is to use the CRM shell commands, and the second way would be using the SUSE Hook web user interface. Let's start with the CRM shell commands. So from any node, I will be executing the command crm1-rnf. The cluster is working fine. The SAP HANA Master Resource Agent is working on HANA 01, and the Slave Resource Agent is working on HANA 02. From the other perspective, the SAP HANA System Replication Show Attributes commands provides an overview of the HANA System Replication status and more. Again, from any node, execute the SAP HANA System Replication Show Attributes command. So from second node here, I will be executing the command. HANA System Replication is working fine, and the HANA 01 is the current primary database. So this was the command line way. What about hook? Let's log in using the HA cluster user. The status page shows that the cluster is working fine, as we can see here. For example, the Master Slave Resource Agent for SAP HANA here. And the dashboard page shows that the current master SAP HANA resource agent is working on HANA 01. What I'm going to do now is to show you how the SUSE high availability cluster detects a complete breakdown of the primary database system. In my case, the primary HANA database is working on HANA 01 and secondary HANA database is working on HANA 02. We can see that from the command line using the CRM1 and SAP HANA system application show attributes commands output. Let's watch the cluster status from the secondary HANA database HANA 02 using the CRM shell command. Then I simulate a complete HANA breakdown on HANA 01, which is the current primary database. I use the command http kill -9 to simulate database crash. Just a few seconds and the SUSE HA cluster detects the database crash on the primary database and marks the resource as failed. The cluster promotes the secondary HANA database on HANA 02 to take over as primary, as we can see here. I need to check the HANA system application status using the SAP HANA system application show attributes command from HANA 01. So I log out here and then I execute the SAP HANA system application show attributes command. It needs extra few seconds to detect the system application failure. So I will execute watch SAP HANA system application show attributes command. Okay, now it shows the sync state of the stopped primary on HANA 01 as failed. Because the SAP HANA resource agent automated register parameter is enabled, the cluster restarts the failed HANA database and re-registers or registers it against the new primary. We need to wait for another few seconds until this happens. Okay, now here we see or we can see the system replication status on HANA 01 updated to be SOK or system replication OK. So everything looks fine to me and everything is okay. Thank you for your time. Thank you all for your great participation. And finally, we look forward to hearing from you.